Good morning all. Myself Ramya, working as Associate Professor in the Department of ECE, Hindustan College of Engineering and Technology. In this presentation, I am going to discuss on the overview of the Supervised Machine Learning Algorithm in the course Machine Learning. The contents which I am going to discuss today are Machine Learning. Under that, the major category is Supervised Machine Learning. The introduction of it and the types of Supervised Machine Learning are discussed, with various algorithms involved in Supervised Machine Learning algorithms are discussed, and finally advantages and disadvantages of Supervised Machine Learning is also analyzed. Machine learning is nothing but learning by a machine. Generally, humans will learn from the past experiences, whereas machine tries to follow the instructions given by the humans. Now, but because of machine learning, the machines can automatically learn from the data, and it can improve itself based on the analysis, and finally it can predict the data easily without being explicitly programmed. In short, the machine try to imitate the way that humans learn. The major category of machine learning is supervised machine learning. Supervised machine learning means that the input and as well as the output data are already known. And the main concept behind supervised machine learning model is that the machine learning algorithm try to find the best mapping function between the input and output. For example, here the input which we are providing is the image of apple. In addition to the image of apple, the annotations for it are also provided to the model to get trained. So annotations are these are apples. So the model will be trained for the respective image as apple. So whenever a new data or new image is entered into the model, is given as input to the machine learning model tries to predict it as an apple because it has been already trained. So supervised machine learning means that the learning happens simply like the supervisor supervises the learning process. The supervised learning algorithm is classified into classification and as well as regression. Classification provides the discrete variable as the output, whereas regression provides the continuous variable as the output. This figure shows the basic example of classification algorithm. To this machine learning model, we are providing the label data, that is with various shapes are available: square, rectangle, triangle, hexagon, circle likewise. In addition to that images, we are providing the labels also as the input to the machine learning model. So the model gets trained and it tries to learn the different shapes and its labels. So whenever a new test data is provided as an input to your machine learning model, the machine can able to predict it easily and it can classify it as triangle or circle. This is classification algorithm. Whereas regression means that it provides a continuous output. For example, x-axis in this graph corresponds to the number of years of experience and y-axis corresponds to the salary. So for various numbers of years of experience, the salary will be provided. So this green dots shows the xy coordinates. So depending upon the inputs, output salary will be getting varied. So it is a continuous output. Regression problem defines the continuous changes. Various algorithms used to make the machine learn by supervised learning is decision tree, preferably for binomial classification, random forest algorithm for multi-class classification, k-nearest neighbor algorithm, and support vector machine. Decision tree algorithm means that the solution is arrived by the machine based on yes or no situations or if then situations. So it usually tries to mimic the human thinking ability while making a decision. So for example, a person is provided the job offer, and he has to decide whether he has to accept it or decline it. So he has certain criteria to analyze the job. First, he will check the salary. If the salary criteria is satisfied, he will check whether the office is nearer to home. If it is also satisfied, he will check whether the company provides a cab facility. If all these conditions are satisfied, he may accept the offer. Else, he may decline the offer. This is decision tree algorithm. The next one is random forest algorithm. Here, this algorithm preferably used for multi-class classifications. Here various decision trees are implemented and the input is provided to all the decision trees, and each decision tree will apply its own algorithm and provide the output. Among all the possible output, majority voting is considered and the output class is determined. For example, here tree 1 and tree 2 decides the input as apple, so majority voting is apple, so that becomes the final output. The next algorithm is k-nearest neighbor algorithm. K-nearest neighbor algorithm actually helps to analyze the new data whether it fits into the similar class which is already categorized. For example, here category A is mentioned in green color and category B is mentioned in blue color. Whenever a new data point is entered here, we will check how many neighbors are there in each categories. For example, here this new data point has 3 neighbors in category A and 2 neighbors in category B. This shows that this data point has to be brought into the category A. This is k-nearest neighbor algorithm. So, in detail, for example, if a person A is listening to that song, and obviously we have seen in various Alexa or Amazon or various applications we have seen, obviously the suggestions will be provided to us. When a new song is released, we have to provide a suggestion to person A. The machine has to provide it. Generally, the song will be categorized or analyzed based on its tempo, genre, intensity, genre of voice. Person A will preferably likes the song when the song has fast tempo and soaring intensity. So this green dot corresponds to the liking of his preference of his songs, and this corresponds to dislike. So whenever a new song is released, we will fit into this graph with tempo as the x-axis and intensity as the y-axis. So this fits into this category, fast tempo and high intensity. And similarly, one more song is released, we are trying to fit it and it comes here in the mid of these two clusters. And this new song A has various neighbors which are preference to this person A. So we will decide, the machine will decide that this song is a preference song by person A. This is k-nearest neighbor algorithm. The next algorithm of supervised machine learning is support vector machine. Here the input data is categorized based upon the hyperplane, the boundary which is decided between the two classes. So this is class A, this is class B. They are separated by the hyperplane. So for example, if we have the input and the model is trained with cat and dog, these are the past label data. Whenever the new data enters into the model can be able to easily analyze it as cat, depends upon its position, depending upon the feature's position either in the left side of hyperplane or on the right side of hyperplane. So this SVM algorithm can be used for face detection, image classification and text categorization. Next comes the advantages of supervised learning. This supervised learning is easy to understand and it is the most common type of learning method, whereas here only training data is enough for training the model, and we are aware of the output number of classes, and it is very much helpful in solving real world computational. Whereas it also has certain disadvantage. Here this performance is limited and it can't able to handle complex problems and it cannot create labels of its own. And if we enter the new data and if we haven't trained already, definitely it won't be provide a good result. For example, we have trained with apples and orange, and if the new input data is watermelon means obviously the model will get fail. It won't be providing the proper output. And this model requires the processors of good quality, high computational power. So in short, supervised machine learning helps to solve various types of real world computational problems, and it helps to optimize performance criteria with the help of experience. It helps to solve difficult real world problems, creating new opportunities in business, engineering and many other application areas. This learning method can also help the model to learn from previous experiences and to improve its accuracy in prediction.